Hello, I'm Darlisha D'Ambert, and for to be discussion video, I will be talking about exogenous and endogenous pathways of antigen presentation. I found this picture on Google. It kind of helped me visualize what I'm talking about, and it will kind of help me back up what I'm explaining to. So, in visual presentation. So, I'll kind of point out some things that are on the picture that I'm explaining to. So, starting with, we know that an antigen is a molecule or a substance that reacts to a product of a specific immune response, and it stimulates antigen growth. It can go through an antigen process and mediation via the antigen presenting cells, and those are which are APCs. Example of this can be dendritic cells. Antigens, they're classified as mutagens, tolerogens, or allergens, and their origin, also what we'll be talking about today, is exogenous or endogenous. So, beginning with exogenous antigen, majority of antigens are exogenous. These exogenous antigens, they enter the body via infectious agents such as bacteria, viruses, fungi, protozoa, things of that nature. They can also enter the body through environmental substances such as dust mites, or around springtime when the pollen is in the air. So you inhale that pollen, so that goes into inhalation. And they can also enter through the body as through ingestion or injection. So these antigen presenting cells, they intake exogenous antigens through endocytosis or phagocytosis, and they process into fragments to initiate antigen processing pathways. So after this, initiation of pathways, the fragments go to the surface of the membrane with MHC class 2 molecules, and they're recognized by T helper cells, which is what you see in this little corner right here in the left corner. So going to endogenous, and I didn't say that exogenous pathways, antigens, they are MHC class 2, and endogenous is MHC class 1. So endogenous antigens, they occur within the cell because of the normal cell metabolisms, or intracellular bacteria or viral infection. So it kind of depends on those things that are occurring inside the body. So these endogenous antigens, they're found in the cytoplasm of APCs as self-cell proteins, and they're also covalently linked to ubiquitin. And what that means is that there are no active phagocytosis occurring at this point, pretty much. So after initiation of antigen processing pathways, these endogenous antigens are degraded and are generated peptides by proteases, and the peptides are presented by making a complex with MHC class 1 molecules on the cell surface. So next, the TCYT cells, they begin to secrete compounds that cause lysis. So an example of all this for endogenous antigens, there's self-antigens, tumor antigens, alloantigens, and some viral antigens. So those are a few examples of what those endogenous antigens are. So just a quick summary of the main differences of endogenous and exogenous antigens. We know that exogenous antigens, they're foreign agents, and they're entered from the outside of the body. And endogenous are the compounds generated within the body. So that's one. Exogenous, they're actively taken into antigen presenting cells, whereas endogenous, they're already presented within the body, within the cytoplasm of antigen presenting cells. Exogenous antigens, their active phagocytosis are required to take up exogenous antigens, where endogenous does not. Endogenous antigens, they have their tumor or virus deprived products. Exogenous, the product of viruses or bacterial cells that are processed by antigens, are presenting cells. Endogenous antigens, they're recognized in association of MHC class 1, and exogenous, on the other hand, they're recognized in association of MHC class 2. Exogenous, they're presented on MHC class 2 molecules. They are recognized by T8 cells, so T helper cells, whereas endogenous, they are MHC class 1 molecules, and they are recognized by TCYT cells. So that is what I got from it, and kind of what this picture kind of helped me visualize what kind of what is going on within. So I do not mind if you use this video, and I hope I explained it the best I could. Thank you.